Hi everyone, welcome back. On today's lecture series, we are going to see about the distance relay. Okay, so in that distance relay, a definite distance type impedance relay. So here, the definite distance type impedance relay, it consists of a pivoted beam and two electromagnet which are energized respectively by a current and voltage transformer, okay, in the protected circuit. So it consists of two electromagnet. One is energized by the current coil and another one is energized by the voltage coil. The armature of two electromagnet are mechanically coupled to the beam. Okay, so the armature of two electromagnet are mechanically coupled to the beam on the opposite side of the fulcrum. The beam which is provided with a bridging piece for a trip contacts. The relay is so designed and the torque which are produced by the two electromagnet are in opposite direction. So this is a schematic diagram. So this is one electromagnet and this is another electromagnet, and this electromagnet is connected with the potential transformer in the power system. So the potential transformer, it provides the voltage to the electromagnet, and this coil is connected with the current transformer of the power system. So this current transformer, it provides the current to the electromagnet. So these two electromagnet, it operate, one is operate with the voltage, another one is operate with current, and it is connected with the pivoted. It is nothing, it is at the point of F. Okay, and this is nothing but an armature. This is nothing but an armature. So here one piece is the one armature is there. Here also one armature is there. Okay, la. So in middle of the armature here, it is connected with the trip circuit. It is connected with the trip circuit. Okay. So under from the PT and from the CT, the flux produced from the first electromagnet and the flux produced from the second electromagnet, if both are equal and it carries a both electromagnetic power, so the armature is in under balanced condition. It is in balanced condition. It will not move any of the direction. Once any of the electromagnetic force, either voltage based electromagnet or current based electromagnet, it exceeds the preset value, so that any one side the electromagnetic power is maximum. So during that specified side, the particular the armature will be attracted by the electromagnet. That will be attracted by the armature. So once, now we can imagine, now if the fault is occurred, the current will be maximum, so the coil is getting over excitation. So because of this over excitation, the armature will be attracted by moving the armature to the downwards. So this particular element moves in the forward direction, that is clockwise direction. So this iron piece, it touches the two contact of the trip circuit, so it gives the information to the circuit breaker to isolate the faulty section. Okay, so under the normal operating condition, the pull power, it is due to the voltage element or it may be a current element. The voltage element is greater than, it will not operate. At normal operating condition, the force due to the current and voltage. So when we are comparing the both voltage and the current, the voltage element is maximum. So therefore, the relay contact remain in open position, so under normal operating condition. So when the fault is occurred in a protected zone, the applied voltage to the relay, it decreases. The voltage gets decreases and the current gets increases. So because of this, the restraining forces gets decreases and the operating forces gets increases. The ratio of voltage to current with respect to the impedance, it falls below the predetermined value. So therefore, the pull of the current element will exceed the particular predetermined value voltage element, and this causes the beam to tilt in the direction to close the circuit breaker. And this is an assessment. And distance relay, it measures impedance of the protected line, voltage at a different point along the line, current flowing through the line, and power factor of the line. So put your answer in the comment section, and these are the few reference books for this electromagnetic relay. Thank you.